Hi, I'm Siddha, and in this video, I will talk about producing bar chart animation in art. First, let me clear the objects in my environment by using the rem function, rem command. I'm going to use the libraries tidyverse, readxl, dplyr, and ggAnimate. So the data that I'm going to use here is the COVID data by countries across the world that is recorded on a daily basis. And the data source is the website of European Center for Disease Prevention and Control. So I have downloaded the data from this website, and you can also download the daily data on COVID cases across the countries from this web page. So I have downloaded the data and saved in my working directory. The working directory is the October 31st folder in my desktop. So let me set the working directory by using the set wd function, and let me read the data. So I have downloaded the data and put the data in my working directory and named it as the COVID DEC foreign. So by using the readxl package and the readxl command, I have imported the data in my art. So this data set contains, let us have a look at the data. This data set contains 61,900 observations on 11 variables. The variables include the date of reporting, the cases, dates from COVID, country, geographical ID, country code, population, and continent. So few data manipulation here. The first thing I'm going to do here is let us have a look at the first few observation by using the head function. So we have the date, but not in standard format because the extra information here. So we wanna have simply this year, month, and day. So all other variables are okay for us. So the first thing I'm going to do here is to create a new variable called date that has a date in a standard format, year, day, and months. So by using the age.date function, I am creating a new variable called date simply by converting the date report variable to a new date format. So if I run this command, a new variable is created, and we can have a look at the first few observation of this variable. So now the variable date reporting was not in a standard format, but the new variable date is now in a standard format that has only information on year, month, and date. So a few other manipulations, since the name of the countries are long for US and the UK, and for the International Convention Center in Japan that has COVID cases, we will just shorten them. So we will replace United States of America by USA, we will replace United Kingdom by UK, and the last one by INTL, Convenience Center Japan. So this just replace the name of United States of America by USA, United Kingdom by UK, and the cases on International Convenience Center of Japan by INTL CB Center Japan. So these are just for making the name of the countries precise. Okay, now let us go to the next step of data preparation. So our data our data is the daily data. It is the daily number of cases. So the first thing we want here is to find the total cases by day. So we have to make a cumulative total of this data. So what we will do here is we will group the data by date and find cumulative totals. So for that we will use the piping function from the dplyr package. So we will create a new data frame called data new. So this is simply by selecting the data that we have imported. Then so this symbol, which is the piping function, can be typed in R by pressing Control Shift and M. So and this can be read as then. So first consider the data file data, then select country, cases, date, continent. So we just want 4 variables, so we will remove other variables and save the 4 variables in the new data set. So for that we use the select function. So it selects the country colon, cases colon, the date colon that we have created, and the name of the continent colon. Then we group the data by continent, country, and date. So we group the data first by continent, then by country, and then by date. Then we summarize the data by finding the total cases, as the sum of the cases. So if there are no duplicate results for a single day, this line is irrelevant, because we have arranged the data by date, and if there are no duplicate observation for a single day, the sum function will just be equal to the original data, or the summed value will be equal to the original data, because we're summing the cases by day. Then we find the cumulative total. For that we use the mutate function, or the mutate command. We create a new variable called cumulative total equals to cumulative sum of the total that we find in the previous states. So if we run this line of codes, it will create a new data with the same 61,000 observation, but now we have arranged data according to continent, and then country, and then date. So continent, country, and then date. The first date is 2019 December 31st. So total 00, then 2020 January 1st. So cumulative total 0. So if I go, we can see that the cumulative total is just increasing, and since this is the case for Algeria did not have any COVID cases until February 26, and this is the total cases for Algeria on a cumulative basis. So after Algeria, it will start the next country, Angola, and for Angola also it finds the cumulative cases under this cum total column. So next we are going to arrange these cases on descending order, and we're going to select the highest 10 cases by day. So for that we transform the data further. We create a new data frame, data2. by using the data frame that we have created just before minute. So then we just take the data new that we have created, and then we group the data by date, and then we arrange the data by date and minus cumulative total. Means we group the data on descending order on the basis of cumulative total, and then we create a new variable by using the mutate function. The variable is rank, so which goes from 1 to the number of items. Then we filter the highest, or we filter the first 10 observations that have the highest rank. Means we select the first 10, or the 10 observation having the highest COVID cases on that day. So if I run this line of codes, it will create a new data frame called data2 that has just 3,500 observations. Let us have a look at this data frame. So for December 31st, it has selected the 10 cases. It has selected the 10 cases, and it has put a rank on the descending order. So it will be more clear if we go further to the end of the data frame. For instance, for December 14, 2020, there are 10 observations, the name of 10 countries that have the highest number of COVID cases, and we have arranged the data on descending order on the basis of cumulative total, and we have given, or we have assigned the rank as for the number of cases. So United States of America had the highest number of cases of 16 million, followed by India with 9.88 million. So the rank for US is 1, followed by India, and then followed by Brazil. So after preparing this data frame, we are just going to create a static plot. So the static plot here will be 350 static plots. So it will take a lot of time to create those plots, because the plot will have 350 charts within it. So we are going to use the ggplot package for this. So we take data2, then we use the ggplot function, and we define aesthetics. We define the x aesthetics, x mean, x max is the cumulative total, aesthetic y minimum is the rank minus 0.45, y max is rank plus 0.45, y is the rank, and few other specifications. We want to fill the bars. We want to fill the bars by continent. So for each country, there will be a different color pertaining to the continent. So this is for the color scheme. So we declare x to be continuous, and we define the limits for x-axis from 5 million, minus 5 million to 16 million. And there will be breaks on the x-axis for making more readable, and we define the labels. The first label is the name of the country, which is just put to the left of the y-axis. So we have defined the x coordinate to be minus 100. So another one is the cumulative total. So the cumulative total will be shown in a fixed position of x equals to 12 million. So few other specifications, we give the GG title, x level, y axis level, and we specify the theme to be the classic one. And we save all these plots under the object my plot. So if I run this line of codes, it will create an object called my plot and saves all those static plots inside my plot. So if I run this, one object is created called my plot. So it saves all the static plots, all the 350 static plots in our case. So now we are going to animate the plot. For that, I'll just add some specifications to my plot. So my plot, then we add one label. The label is the date. The label is the date, and its position will be 8 million. X value is 8 million, y value is -10, and the size 12, color green. And finally we want to animate the bars by date or on a daily basis, so we use transition time equals to date. So if I run this line of commands, it will create an object called P, in which this animation by date is saved. And now finally I want to create this animation. For that I specify few parameters. I want to animate this object P, and number of frames 350, because I know that there are 350 static plots, because there are 3500 observations, 10 observation per day, because we have filtered the top 10 values. So 3500 observations converts to 350 days of static plots. So I want to animate this by using the GG animate package. The number of frames 350, and so the speed of change in frames is frame per second is 5. I want the rate of the animation to be 1000. So if I run this line of code, it will first combine the frames and then combine the frames into an animation, and the animation will appear here under the plot section. So since there are 350 frames to be produced and combined, it will take some time to produce those frames and combine them to produce the animation. So the creating process has started. It is creating 3 frames per second. So at this rate, it will certainly take some time. So let us just wait for a few seconds until the process is complete. I want to share the technique for saving this animation in our working directory. So we can save this animation either in the GIF format or video format. So for saving it in GIF format, we simply use the GIF SKI renderer, this option after the animate function, and we can even save this in video format. So after the creation process is complete, we can save either it in the GIF format or video format by using the appropriate renderer. So it's taking longer time than expected. Anyway, it will be complete. Okay, after this rendering process is complete, it will start creating frames, and it will create 350 frames. Okay. So let us wait for a few more seconds. It's saying that almost 4 seconds remaining. Okay. Okay, now the creation of frames have started. 30 frames. So it will create 350 frames. Okay, 130 frames. So we can reduce the number of frames by changing the parameter here, but the quality of your animation depends on the appropriate combination of these parameters. So I've used here as the number of frames to be equal to the number of days, and I have used the frame per second to be 5. Let us see how the animation looks like. So okay, almost complete. So I will enlarge this for a few seconds. So it has created the animation here, date. So this shows the number of cases. This shows the top 10 countries by date. So the bars will grow, showing the increase in the number of COVID cases by date. So up to July, okay, we see that US, Brazil, India, they had a rapid increase in the number of COVID cases after July. Okay, US has crossed 12 million, 14 million. Okay, so after this animation, we can save this animation. We can save this animation in GIF format or even MP4 format by using the animate and anim save options. So thank you for watching this video. For your reference, I have put the codes and the data file in the description of this video, and do not forget to subscribe my channel